Well, good afternoon. Thank you for being here at our session on Vermont conservation design. We're really happy to be here. What a great conference. It's just, I've learned so much already. And my name is Liz Thompson. I am a member of the board of Northeast Wilderness Trust, and I work with wildlands, woodlands, farmlands, and communities. I'm joined here by Jens Hilke of the Vermont Fish and Wildlife Department and Bob Zano of the Vermont Fish and Wildlife Department. We were supposed to have been joined by Gus Goodwin of the Nature Conservancy. He was unable to be here today due to illness, so we'll do our best to represent him here. I'm just going to introduce the topic a little bit, and then mostly you'll be hearing from Bob and Jens about Vermont conservation design and what it is. But I want to tell you a little bit about why we need it and give you a little bit of a regional context for it. So here's North America. And here's where we are in North America. If you can look at this map, this is a map of forests in North America, and we are here in New England in a really pretty incredible landscape worldwide. We are in a forested landscape that was not always forested, but for most of the last 10,000 or so, 12,000, it was forested. There's a brief period of time when it wasn't. But we are in a really important, globally, regionally important landscape. And this next slide is from the Nature Conservancy. Shows a simulated response of 475 species of birds, mammals, and amphibians to climate change, and how they'll need to move upslope and northward to find suitable homes. And although this is a relatively simple depiction of how species will need to move in response to climate change, it drives home two key points. One, the amount of movement is staggering. And we're already watching it happen in real time, right? You've seen this. Species are moving, and the data show us that species are moving on average 11 miles north and 36 feet upslope per decade. These are large numbers. And also some places are going to support more movement by more species than other places. So if you look at this simulation, you can see that we're in a very important region. So the Appalachians, including Vermont, are one of the places that play a bigger role than other parts of this continent and other parts of the world. And they have before, during the advance and retreat of the continental glacier ice sheets, they provide this area provides safe harbor in the forms of climate refugia and providing suitable stepping stones as species have moved north or south, up or down slope, as the climate has changed over time, over the last number of thousands of years. And this region can play that role again if we take the actions necessary to allow it. So this region is so special because of its diversity, because of the diversity of habitats that it contains, the elevational diversity, the landscape diversity, the different geological settings, and all of those things. That's why it's such a resilient area. So the Nature Conservancy has conducted a huge analysis, and they've been doing this for many years, called the Resilient and Connected Network, and I encourage you to look at that if you haven't. And there is a special focus on the Appalachian region. So TNC's been working with a team of scientists to identify those places that have the geophysical properties to allow species to move in response to climate change and ecological connections. And the best of these places are shown here in the Resilient and Connected Network. The Appalachians, the region, has been identified by the Nature Conservancy as one of 4 priority landscapes in the world. It is a globally important landscape. So this is really, really important, and we here in New England, we here in Vermont are part of that. So the map really underscores the importance of Vermont in connecting the vast forests of the Adirondacks, northern Maine, the Maritimes, and the Central Appalachians. We're at a climate crossroads in a way, and we have an important role to play in the success of conservation in the northern forest. And so another thing I want to do is just show you that these two publications, so I've just talked about the Appalachian region as a whole, and the New England region has received special attention, just the 6 New England states, by Wildlands, Woodlands, Farmlands, and Communities, an organization that I work with. And most recently, we have identified, we've written a report on the wildlands in New England. We're going to talk about that in another session later this afternoon, some of us. But these two reports are important. There's copies of the wildlands report over there if you're interested in seeing a copy. But one of the things in this work, which also has been going on since 2005, really, so about 20 years, is this understanding of the change in forest cover in New England over time. So I said that our region has been mostly forested, but there was this brief period of time in the agricultural clearing of the landscape when a lot of New England and Vermont was deforested. And so, but we now have this fabulous opportunity to because the forests have returned. They are young forests now, but we do have forests. So we have an incredible opportunity. And what this what this Wildlands, Woodlands, Farmlands, and Communities has advocated for is conservation of a lot of the landscape as forest, conservation of agricultural land, and room for human communities, and conservation of wildlands, about 10% of the landscape as wildlands. So now, how does this relate directly to Vermont? Well, 2 recent pieces of legislation, which you'll be hearing more about today, or have already heard plenty more about today. Act 59, the Community Resilience and Biodiversity Act of 2023, important legislation, which really uses Vermont conservation design as its underpinning. Vermont conservation design is critical to the implementation of this law, and it calls for 3 categories of conservation lands that support biodiversity. Ecological reserves, biodiversity conservation areas, and natural resource management areas. And then more recently, we have Act 181, which is the update to Act 250. And this is really a companion piece, as the legislator who authored both of these or championed both of these, Amy Sheldon, describes them as companion pieces of legislation. So the revisions to Act 250 do the same in protecting resilient and connected landscapes, and calls heavily on Vermont conservation design to do that. So looking closer at Vermont, there is the resilient, going back to TNC's data, the resilient and connected network looks like in finer detail at specific wildlife crossings in Vermont and how important they can be in this overall regional picture. And so with that, I am going to pass it on to Bob, right? I'm going to pass it over to you. No, to Jens Hilke, I'm sorry, who is going to talk us through Vermont conservation design together with Bob. And I need to.
All right. Well, thank you all so very much for being here. I'm pretty pumped up to be with you. I've had a lot of coffee. I'm gonna try and keep it calm. Not my strength. So what I want to do is put this in a little bit more context in terms of what are we talking about today. So the conservation design is a vision for the state's valued forests and natural areas. It answers questions like, how much is enough? Where are those important places? It's a prioritization. And so over the course of the next 45 minutes or so, we're going to get a little bit more into that. I really want to start off with why and why we did this, and then we'll get in and we'll show you the overall prioritization, and then we'll explode it into its parts, and Bob will take over and we'll do a deep dive into some of those components. So first of all, I just wanted to be clear, this is very much a team effort. Our first version of the BioFinder website and the conservation design in its infancy was created in 2011. So this is our fourth time of updating the conservation design. And each time we get a big steering committee together with all manner of different partners. So this most recent effort is just really the last group of partners that has helped us form the direction of this. Over the years, we've involved many, many groups. So there was a big steering committee that really was responsible for the direction that we took in terms of the science and bringing different diverging views together. And then there was a core team that really made it go, that took the direction of the steering committee and used the available data to set a direction. And then there was a GIS team that really made it all happen. So I just wanted to lay out that partnership piece before we get into the why, because it's such an important part of how the design has been created and how we do business. So I want to talk about the design in three different ways. First of all, as a prioritization and thinking about that. And I want to talk about the design as maintaining nature and its benefits. And lastly, we're going to talk about this as a conservation framework. So let's just pick up on that a little bit more. As we think about maintaining nature and the benefits that it provides, those intact forest blocks and the connectivity between them allow for plants and animals to move in the face of climate change. So not only is this an assessment of current biological diversity and which places are most important right now, it also looks to the future in terms of where there's going to be biological diversity in the future, even as our plants and animals change. Bob is going to try and stay calm and not get too deep into the weeds with the geological diversity component, because that's really where we address that resilience aspect of looking into the future. And he and I have spent hours geeking out on that particular component and just really love it. It's such an important part of the design. So VCD, Vermont Conservation Design, we can think of it as also as maintaining environmental services. So not only is it this snapshot of biological diversity, but it's incredibly important for providing services to Vermonters. So this started as a science project, and yet it encompasses a much larger suite of values. We can think about this as a climate solution. And again, that idea of allowing wildlife to adapt to a very changing world, I think is really fundamental to how we think about the future and how we integrate the current science into a vision for what we need moving forward. Of course, the working landscape and farms and forests are absolutely represented in this design, and a key part of the values that we're trying to represent here. And of course, the natural beauty of Vermont, the rural character, those intangibles, the things that make Vermont, Vermont. So again, I'm just trying to give you a sense of what's guided this work and why we've engaged in the conservation design, what it does for us beyond the ecological prioritization. So, I mentioned this is the fourth time we've updated it. What's different? Well, at the heart of the terrestrial wildlife, at the heart of the terrestrial landscape layers, is this concept of a forest block, a habitat block. Areas of natural cover surrounded by roads, development, and agriculture. And so over the last 15 years, we've really moved to that forest block as an essential unit in our conservation planning. So we've moved away from the concepts of starting with hotspots of biological diversity and really thinking on a much coarser scale, thinking about these larger habitat blocks. Now, the habitat blocks have increased because of the input data that we use this time around, the UVM Spatial Analysis Lab LiDAR-derived land cover data. Well, it has a 0.5 meter resolution. The data we started with had a 30 meter resolution. So the newer version of the conservation design has a resolution that's 3,600 times better than the previous version of ECD. 3,600 times better resolution. What that really does for us, and what you can see in this example from Goshen, is it really allows us to get a finer sense of, well, in particular, the wildlife road crossings. In the previous version, we had a very coarse scale. And so we just said, well, we're going to remove everything that's close to the roads because we don't really know where the forest blocks are or aren't. Well, with a much higher resolution, it allows us to get a much better sense of where there's connectivity, potential connectivity across the roads, and where there are houses and other features that might limit wildlife movement. So the edges of the forest blocks are particularly better in this round. We are using better wetland data than we ever have. Again, that LiDAR-derived, in this case, the wetland supplemental data was really helpful in adding some areas. There's a more intuitive display of forest fragmentation. In the previous version, we took a density of houses and removed that from the forest block. Now we're taking a 150 meter buffer around the houses and removing it. So there's a very intuitive display of where there's been a reduced quality of the block because of development. Now, the LiDAR-derived data essentially uses canopy height, vegetation height, to tell us what the different inputs the land cover is. So that allows us to get really good idea of where there are trees, right? The tree canopy data is excellent. The open land classes, not so much. So, some of the areas that have been recently harvested and that are part of a forestry operation, in that input data, they're going to show up as lawn, the same as a front lawn in Williston or a golf course. And so we have in some cases, we were able to use supplemental shrubland data to fill those holes, but not everywhere. So in some cases, there are some donut holes in the middle of a forest block that we're pretty sure are going to be maintained as forest, and yet they're called out of the block, again, because of that incredible accuracy in the input. Power lines are another example. From my standpoint, I'd love to have included them. Several wildlife species will use them as corridors. I think while they're not forest, they aren't going to be developed, and so I would have included them in a forest block. But again, because of that input data, it's difficult to discern. So strictly speaking, you should not compare the 2011 habitat blocks and the 2023 habitat blocks. It's very much apples and oranges because of the difference of that input data. And because the edges are better, we've actually shown an expansion of forest. That's not true. That speaks to our ability to detect and not what's actually happening on the ground. So caution. Please don't directly compare those two. It's very much apples and oranges. But from here on out, we can use this same methodology with the LiDAR-derived data to track fragmentation over time. So I made this point earlier, but with the better edges of our forest blocks, it's really been improved connectivity science just dramatically. Because our ability to see those edges really allows us to see where there's habitat that's close to the road that actually connects to those larger blocks. So these changes have just been fundamental to a better understanding of connectivity science. It's really incredible what's happened here. Okay, so the habitat blocks, there are 4,052 of them, something like that, statewide. That's every forest. We didn't learn about any new forest that we didn't know about before. Okay, so we have a better edges on those blocks. There are a total of 4,000 of them. We took a subset of those, a selection of those, as highest priority for different values, interior forest, connectivity, etc. Bob's going to explain those in detail. So we take a subset of those highest priority forest blocks, and we begin with those. And then we add together the entire surface water and riparian area network, everything that's wet, as a starting place for highest priority for biological diversity. Then we add in our highest priority natural communities and rare, threatened, and endangered species. And together we get this ecologically functional landscape. So at the end of the day, VCD, Vermont Conservation Design, is a singular map, right? That ecologically functional landscape. And so you can look at it as a single map. You can zoom way in on it. You use the BioFinder website and you can interact with it in great detail. But we can also explode that into its parts, the interior forest, the connectivity blocks, and look at particular values. Now, I've mentioned this concept of ecological function several times, and it's pretty important for you to understand what we're talking about here. Because as we move our mapping from those hotspots of biological diversity to thinking at the landscape scale, well, the green on the map means different things in different places. It depends what the underlying ecological values are, why that was elevated to be highest priority. So different places on the map refer to different functions and values. And so you need to drill down into the design to figure out what the ecological function is that's being captured in a particular place. So, as we think about this larger design, 3 words: intact, connected, and diverse. And that really is guiding our thinking as we talk about this landscape scale transformation, really making sure that our forest blocks are intact, that they're operating, that they're doing their jobs, that they're connected to one another. Those connections between the blocks are more important than ever. And of course, biologically diverse with the full spectrum of geophysical settings and rare, threatened, and endangered species. Also embedded in the design are different scales. So I just showed you that map of the ecologically functional landscape. When you open BioFinder for the first time, it starts at that landscape scale. It gives you that landscape scale prioritization. We want you to think about that larger pattern first. We want you to get that big picture ecological context first, then drill in, then figure out, okay, well, what's the big pattern here? Where are the big forest blocks? Where do the rivers and streams connect those forest blocks? Where's the geological diversity at that coarsest scale? Now zoom in. What about natural communities? What about wetlands and vernal pools? What about rare, threatened, and endangered species? So we want you to start with that big picture understanding and drill down in scale to get a better understanding. So those places, when you do end up zooming into your house, your parcel, your town, it'll have a much richer understanding. You'll have a much richer understanding because of that ecological context. Bob's going to take over and think a little bit about these different landscape components. Then at the end, we'll have plenty of time for questions and answers. And just before I forget, perhaps unexpectedly, I brought swag. So there is VCD swag. I brought some posters, and I'm happy to give those out for free. I just didn't want to forget, so I'll mention that now. For that very special someone, I'm sure.
I'm not quite so caffeinated as Jens, nor quite as naturally loud, so I'm going to try to keep the volume up with the mic. So you heard the arc of why we need Vermont conservation design. One of the key building blocks, the forest block that we use in Vermont conservation design. Now let's really dig in and talk about how we've prioritized individual pieces that all add up to create that big map. Starting with interior forest blocks, which I think are the most intuitive part of Vermont conservation design. We mapped the 4,000 forest blocks around the state, and then we looked in each region of the state using Vermont's biophysical regions. There's 9 biophysical regions, things like the Champlain Valley, the northern Green Mountains, the southern Vermont Piedmont, the northeastern Highlands. I might as well just name them all, but you get the idea. In each region, we prioritized forest blocks by size and by the amount of core forest, meaning forest that is at least 200 meters from the edge of the forest block. So you can think about, you map this block, this polygon, and then you squeeze everything in a little bit to where you can get 200 meters away from the edge. And if you have a nice round circular block, you have a nice round circular core. If you have a very long stringy block, there might not actually be any forest that's greater than 200 meters from the edge. That block might be only 400 meters wide for that part. So you get a sense of where is the big, deep woods in each region. When you do that, and then you set some thresholds for what cutoff you use, you get this map. And you can see on this that our best interior forest in places like the Champlain Valley looks really different in size than our best interior forest in the Green Mountains or in the Northeast Kingdom. That just reflects our different land use and the different sizes of forest that's out there. And we think it's really important that we have this full representation of the state because different species live in different parts of the state. The species you find in the forest in the Champlain Valley are going to be really different than the species you find in the forest high up in the mountains. Another thing, for each of these components, I'm not going to go into great detail about this here today, but for each of these components, we have guidelines for what it means to maintain their ecological function. So interior forest blocks, we're trying to protect that deep, dark woods, so to speak. So what maintains that? Well, not doing development that punches into the middle of the forest, not building new roads into the center of forest blocks that are thousands of acres in size, not putting new developments right in the center. Let's think about how we can work around the edges of the forest block and minimize those incursions that permanently fragment these big forest blocks. That's for permanent development. Something like forest management is completely compatible with maintaining forest blocks. We consider that successional cycle that happens as part of forest management as maintaining forest. Yes, it might start from a very young successional stage after a timber harvest, but that's going to grow back to forest and stay forest over time. And actually, allowing landowners tools, economic tools and incentives to maintain their forest and manage their forest helps keep forest blocks intact in the state. I'm actually going to go back to that slide for a moment here. You can see that those are the best interior forest blocks in each region, and you can probably tell that they're not all connected. You can't draw a line tying all these forest blocks together because that's just not the pattern of our big intact forests. So we had to think about, well, how do species move between forest blocks? We do not want to just end up with a Vermont in the future where species are stuck in their forest block and they're stuck there forever and they just slowly disappear because that's what we know happens from basic island biogeography, like one of the most basic concepts in ecology. Small areas, populations go extinct over time. So we looked at, well, where could we connect forest blocks? Where are there stepping stone? Smaller blocks that maybe aren't the best in the region, but that could build those pathways to connect these intact forest blocks, the larger forest blocks. And that led us to this map, which we did using a bunch of tools, one of the key ones being Mark Anderson's tee it from the Nature Conservancy, Mark Anderson's analysis of regional flow. How is the region connected if you think about it as like a river where sometimes the water concentrates and lots of things are flowing through, and other places it just kind of gets stuck behind dams or whatever. In this case, stuck by non-natural habitat. So now we've got pathways. And Vermont is at this key crossroads. We connect to the Adirondacks, to the Gaspé Peninsula. We connect the Berkshires in Massachusetts to the Sutton Mountains in Quebec. So all that movement around the Northeast, ecological movement of, yes, wildlife, but also plants, everything kind of comes to a crossroads in Vermont. And this is really applying at the very local, statewide scale, that broad map of movement that Liz showed at the beginning. So now we've got big intact forest blocks, we've got the stepping stones. That still is not representative of the state as a whole, because we're still not getting lots of forest in the lower elevation areas in the valleys. And in some of the geologies and landforms, like low hills or wet flats, that just weren't really something that was left as forest. There were places that might have been developed frequently, like our sand plains or clay plains turned into agricultural fields. We don't have a lot of natural habitat in some parts of the state. But that's really critical. That's where we have some of our rarest species in these unusual, poorly represented habitats. So we went back again, and we came up with a set of blocks that we call geological diversity blocks. It's a little jargony, but it's a set of blocks that collectively represent the full range of geology, elevation, and landform found in Vermont, roughly proportional to how they occur in the state. So if there's some, the rare limestone-loving mini maple or whatever hypothetical species you can come up with that needs a very particular combination of geology and elevation and whatnot, hopefully there's a spot for that in our design. That's just thinking about now. This gets even more critical. Jens was right, I was going to get excited about this. This gets even more critical, and this is the key to our natural climate resilience. When we think about what species need in the future, we've got something like 20 to 40,000 species in Vermont. All of them are going to be responding individually to climate change and all the other pressures put upon them into the future. They are going to need to move, and we know that species can do that. Species moved here after the ice of the continental glaciation melted away. There was no life here for a while, and it all moved from places further south. And that same thing is going to happen again in response to climate change. Species need space to move, and they need to find that right combination of climate and physical setting to get to where they need to be in the future. So the more options we can give species, the more likely they can shift their range, be where they need to be in whatever the future climate brings. This map of blocks is how we do that in Vermont conservation design. This is building that resilience for the future, because we don't know where all the species are now, and we certainly don't know where they'll be in the future. We just need to give them room to figure it out on their own. And that's the sort of data we use to come up with that set of blocks, just to give you a sense of what we were dealing with in trying to think about this. Jens mentioned the surface waters and riparian areas. Not a whole lot more to say about it other than to, again, emphasize that water is connected, it's flowing, it's constantly cycling. Every place that is a river, stream, lake, or pond is critical to ecological function, and the land adjacent to those areas, sometimes it's very narrow and sometimes it's very broad, like in the Otter Creek Valley in Addison County, or Rutland County. All that land is critical, and it's all highest priority in Vermont conservation design. It might not all be forest now, it might not be that all of that is always going to become forest, but we need to think about maintaining ecological function in those areas, and particularly doing a good bit of restoration of riparian areas. Those places also then form connections, threads that tie our forest blocks together and allow species to move when there aren't even forest blocks that can be stepping stones. And that's the case in a lot of the Champlain Valley. If species move between patches of forest, it's following rivers and streams. Here's an example of that. Can I point? Yes. Can I see? Barely. This is Snake Mountain that I bet a lot of you know. And this is Buck Mountain. This is over towards Bristol, I think. And here's Dead Creek and the mouth of the Otter Creek. And just to show that these orange areas are forest blocks, and then the blue and the brown show those riparian areas, and just how, if we're going to connect like forests here at the mouth of the Otter Creek, which have some really neat natural communities and rare species, the way that those connect up into the mountains is by the riparian areas along the rivers. Those pieces, those three types of forest block prioritizations and the surface waters and riparian areas, form that landscape scale of Vermont conservation design. On top of that, we can layer in finer pieces. And I think you could picture, just by conserving the functions of those forest blocks and riparian areas, we'd be protecting many of Vermont's species now and into the future. But if we add these next parts in, we get even more confidence. And so I'm just going to list these now, but then talk about a few of them. There's natural communities, there's rare, threatened, and endangered species, there's, you can read this better than I can, underground habitats, young and old forests, grasslands, aquatic habitats, road crossings, vernal pools, and wetlands. Vernal pools are a type of wetland, but we wanted to make sure to call them out specifically. Just want to talk about a couple of these. Natural communities. This is what I work on specifically. We have 97 different natural communities that we recognize in Vermont. They're patterns we see across the landscape over and over again. Things like hemlock forest or cattail marsh or this limestone bluff cedar pine forest. Each one of those 97 natural communities that we see again and again has predictable patterns of its physical setting, its natural process, and then the species that are there. And so I think you can kind of get that intuitively by looking at, here's 4 other natural communities. The species and the processes that drive why the species are there on top of Camel's Hump are very different than what's happening along the West River in Jamaica, or on a red oak forest or a black gum swamp down in Vernon. As the climate changes, the individual species in each of these natural communities is probably going to change quite dramatically if we think out like a couple hundred years. But I think we can have some confidence that the top of Camel's Hump is always likely to support different species than what's in the river shore or the basin swamp or the mid-slope hillside. And so this is just, again, bolstering that climate resilience so that we have all the species we have now, and that as we go into the future, new species can find whatever place they need to be suitable, to find the suitable niche they need in Vermont. So we continue to have thriving biodiversity, even if it's a totally different suite of species than we have now. Key to that movement is wildlife road crossings. It's great to have big intact forest blocks and stepping stones, but if species can't get across roads, they're just hitting dead ends. And so we need to think about where there is good natural cover like forest on either side of our roads in places that are essential for movement. And sometimes, how do we get species over or under roads, mostly under roads? Thinking about culverts and bridges. And we did a whole assessment looking at the forest using this very high resolution data on either side of all the roads in Vermont, class 3, 2, and 1. And we sort of boxed it out and calculated the forest on one side of the road and then on the other side of the road and looked at where those were both high and so forth. And in the end result is you get a map showing priority areas where there's good cover on either side of the road. Usually that means that if there's good forest on either side of the road, good cover, it's pretty easy for species to move. But that's not always the case, and that's where thinking about things like bridges and culverts becomes particularly important. Just as a current example, the Fish and Wildlife Department, Jens, mostly has been working really closely with the Agency of Transportation to look at one culvert under Route 2 and 89 between Montpelier and Waterbury to think about how that could be really revisioned to promote and really reconnect the northern Green Mountains north of 89 to the mountains south of 89, create a big passageway for species to move back and forth. Vermont conservation design also has targets for certain conditions, things that we might not be able to easily map, but that are really critical parts of a functional landscape. We have targets for young forest, old forest, shrublands, and grasslands. Grasslands and shrublands support a whole suite of species like bobolinks, golden-winged warblers, and they're really cool habitats. We get them through our management of those fields, either mowing them frequently, but not too frequently, and I think they're intuitive. I want to focus a little bit more on the young and old forest, because this is a really key part to, we need forest, but we also need to have the full range of forest structures and conditions across the landscape. And Liz showed that slide of the change in forest cover over the history of New England, the past couple hundred years, where we lost almost all our forest, and then it grew back, and it's still relatively young now, less than 100 years old in many places. Because of that, the structure of our forest has been really, really simplified compared to the forest that was operating primarily under natural processes before the huge changes that have happened on this landscape in the past 400 or 500 years. There was much more old forest where the trees were growing old, they were dying, falling down, creating this very complex messiness in the forest. When you have big trees, hollow trees, snags, root wads tipped up 30 feet in the air, that sort of stuff, you get all sorts of niches for many, many plants and animals. And we know that in the Northeast, we may not have particular species that are old growth dependent, but there are many, many species that are much more abundant in the forest when we have that structural complexity. And my guess is there are fungi and mosses and lichens and things that actually are dependent. We just don't know what they are yet. So Vermont conservation design calls for bringing back, through restoration, roughly getting to about 10% of Vermont's forest as old forest. I think right now we're somewhere less than 1%. It's minuscule, the amount of forest that has that full structural complexity. So if we could get to 10%, that would be a very significant reintroduction of that condition of the forest. On the other side of the scale, because our forests are relatively young, there's not much natural disturbance happening in our forests, and we don't really have forest management at the scale that creates huge areas of new cutting in the state. And so we actually lack young forest, the very youngest forest, where the trees are only 15 to 20 years old or younger. That really dense regenerating forest is critical to many species. And there's a whole suite of something like 54 species that are really dependent on that condition. And if it's not there, those species are almost entirely absent. And so prior to the arrival of Europeans, when much of the forest was being disturbed through large-scale, say that more precisely. When most of the forest is being, when most of the large-scale disturbances in the forest are happening through wind or fire, you would expect that in our forest about 3 to 5% of it would be young forest. Right now, depending on what region of the state you're in, that percentage is somewhere between 0 and 5%. So the species that would depend on young forests are lacking that habitat compared to what was here, say, 400 or 500 years ago. So if we can bring that back too, and that's probably going to be a mix of natural disturbance and forest management that gets us to maintaining those habitats. When we put all those pieces together, that's what gets us to an ecologically functional landscape. Having everything. It's not a buffet where you can just pick one thing like, you know, I want interior forest, but I don't really think we should do connectivity in Vermont. We need the whole suite of features in Vermont conservation design to get that ecological function. When we do, we're really working then at this landscape scale. This whole idea of being efficient in conservation is something that's been well recognized in the scientific literature. It's called the coarse filter approach to conservation. The idea that we can't conserve 20 to 40,000 species one by one, we'd go insane. So we need to have an efficient way to go about it, and finding these bigger features is the way to do that. The flip side of that is it also helps us understand which species really need our focused individual attention. What are the things like spiny softshell, where if somebody wasn't actively helping that species by protecting its nesting sites from trampling, what species would blink out if we couldn't do that? And so it helps us be efficient in how we are conserving the landscape and how we're doing those individual species restoration actions. We're actually using this idea of coarse filter conservation and Vermont conservation design as the foundation for the update to our wildlife action plan, which is the Fish and Wildlife Department's vision for how we protect all this suite of great species of greatest conservation need. And going beyond just the idea of thinking species by species and how do we conserve wildlife efficiently and broadly. And this is really being baked in as our framework for that. Jens talked about how Vermont conservation design is something that was a collaborative effort that had the input of many, many people. Achieving the vision in Vermont conservation design also takes, I think, is going to take a crazy amount of collaboration, and it's going to take all the range of conservation partners in the state. It's not something that any one organization can tackle on their own. And I think what's so great is that it shows how someone or some organization may focus on some particular part, like young forest, like connectivity, like old forest, and how doing all of those things feeds back into this bigger whole, and that the sum of all this is really much bigger than the parts that we might each individually work on. And I think that's so neat, and it really shows the value of why we need all this work, that's all the people and work that is represented here today. That's how we get to this ecologically functional landscape. That's a group of VTrans employees, by the way. A piece that I am not an expert on by any means, but I want to share that this data is out there. There's the BioFinder website, which is biofinder.vt.gov, I think, but you can find it. It's an interactive map that will show you everything that is up here. In addition to just showing these scientific layers, we've added in some available data on social vulnerability. And I think this is really intriguing. It's something that I'm excited to learn more about and to think more about, but just these ideas of being able to overlay. So we've identified scientific-based conservation priorities. Well, what does that mean in a social context? Because you saw that green in priority is not evenly distributed around the state. What does it mean to have something like that? How does that affect the people who are there? The people there now, the people in the future? There's so much to dig into. I am not the person to dig into that. I'm a conservation biologist, ecologist, but I think being able to do that is key to how we implement this. Here's just some other stats on this design, courtesy of David Fox at the Nature Conservancy. Just some really cool stuff. I won't try to read it all to you, but you get a sense of how our design intersects with some features on the landscape and with other conservation designs, because there's a lot of great synergy, and there's also a lot of great progress towards it. One of the things that's exciting is with Act 59, we'll be doing a deeper dive into the conservation status of these different parts of VCD over the coming months, and hopefully have even more data to think about how are we doing, what do we do going forward to achieve this vision. And that is our somewhat whirlwind tour of Vermont conservation design and all the pieces to it. Thank you. We have plenty of time for questions and discussions. I think Liz is going to help lead us through this. And we have a microphone for...
Right, so there's plenty of time for questions, and why don't you just go ahead and raise your hand, and someone will bring a mic to you. And if you could say your name and affiliation if you want to, you don't have to, but that would be helpful.
Is this the right distance? I'm Becca Warren. I work for the Vermont Sustainable Jobs Fund. And I would like to hear about how agriculturally productive working landscapes are part of or not part of the conservation design, if that's possible.
Yeah, great question. Thanks for that. So agriculture fits in, I think, in one really obvious way, which is that agriculture is what creates those shrubland and grassland habitats. Sometimes hand in glove with the production aspect and sometimes incidentally to it. I think at the larger scale, there's a synergy between maintaining that ecologically functional landscape and the parts of VCD and the ecological functions that support a robust agricultural system. So I think that the way I look at it, having intact, connected forests that support not just like the obvious plants and animals, but our invertebrates, our pollinators, microbes that can travel between places in the soil. All of that, I think, supports our overall healthy landscape. And it's an area that I'd like to actually dig more into and learn more about some of those connections to be able to articulate them more specifically. But I am convinced that maintaining functional natural systems helps maintain those agricultural systems too. The third thing I think I would say to that is that by understanding where we have these ecological priorities, I think that helps us understand where we can do all of the other land uses that we have to do here in the state. We have to be thinking about agriculture. We have to be thinking about how we can have affordable housing. And to do that well and to balance that with maintaining ecological function, we need to understand what to prioritize where. And that's what I think Vermont conservation design can help us do. It might not be everything to answering those questions, but it gives us a lens into, well, what are the ecological priorities? Now that we know the ecological priorities, what do we do with the other areas? How do we best manage and utilize those places? So I hope that gets at what you were asking.
Hello. My name is Bob Galvin. I am a board member of the Vermont Wildlife Coalition. First, just want to say thank you to all three of you and to everybody who's worked on this. This is, yeah, exciting and impressive. In light of what the keynote speaker said earlier, this idea of what are we sustaining, what are we preserving, when I think about Vermont conservation design, I'm wondering, are we looking at wildlife populations as they currently exist or as we want them to exist? I'm thinking particularly in the context of white-tailed deer, where in many areas throughout Vermont, the Fish and Wildlife Department has noted that concentrations are higher than the department would like. So I'm just kind of wondering how wildlife populations factor into the design.
Let me start with just one thing, which is that as they currently exist or as we want them to exist, in a large sense, neither of the above, really. We're creating a stage, we're creating a connected landscape for wildlife to move, for animals, plants, and other organisms to move as they will over time. We don't know what the future is. When it comes to white-tailed deer, I'm going to pass the mic to someone else.
That's a good question. And I think you are right in saying that there is an overabundance of white-tailed deer in certain parts of the state, and that has implications for the forest because of the browse levels. There's actually parts of the state where we can't recruit enough hunters, as I understand it, to actually manage the deer down to a population level that would be more sustainable. Yeah, I mean, we face all sorts of challenges, and that's just one of them that is between us and I think that full ecological function. But back to what Liz said, we can do as much as we can to really maintain and set that stage. And then, yeah, we still have to do other things too. We have to think about overpopulation. Of deer. We have to think about the things like invasive species and how those are going to intersect with the future of the functional landscape. We have to think about other challenges. Now I'm drawing a blank to pull one off the top of my head, but I think you get the idea. Like there's, well, even, or something like wildlife diseases, like white nose syndrome for bats. There's still going to be other challenges, but if we can maintain the functional setting, I think we're just that much better prepared to deal with those challenges.
Other questions? Yes, back there. You could run the mic back there. Thank you.
Hi, I'm Emily Finnegan. I work for the Caledonia County Natural Resources Conservation District. And my interest was sparked in the beginning when Jens, I think, said something about flood resiliency and how, so I'm wondering how I would use this tool to think about flood resiliency for communities in the way of, like, if I'm focusing on a certain parcel or a certain area, how could I use this biofinder to say conservation of this particular area will help with flood resiliency? I'm sure I can't pinpoint it to that way, but I guess I was just wondering if you could speak a little more to that aspect that you mentioned and how biofinder sort of like brings those possibilities to light.
How does this tool relate to flood resiliency? I'll give you this one.
That's a little bit better. Right on. So you said conservation districts, right? Yep. So so I work with municipalities across Vermont, and I think one of the advantages of Biofinder is that ability to zoom in and zoom out and provide that ecological context. So when I work with municipalities, they tend to think inside the box, just like landowners. They zoom into their parcel and they really think inside their box. And what Biofinder allows you to do is zoom out and see that larger ecological context. So as we talk about flood resiliency and working with communities and some of the excellent tree plantings and culvert work that the conservation districts do, Biofinder will allow you to sit down with those volunteers, those people that you interact with, and get that larger ecological scale. Oh, look, where we're doing this tree planting is actually part of a much bigger connected system. Oh, look, where we're installing this new culvert actually allows for connectivity and opens up miles of quality habitat for new, previously unavailable habitat. So that ability to change scales, I think, is really critical as we think about flood resiliency. Another piece that Bob got at, the difference between the surface waters and riparian areas data set and the riparian connectivity data set is essentially the difference between what we consider ecologically functional, what we consider ecologically important for the entire surface water network, and what's actually vegetated. So the difference between those two are places where we really should be thinking about restoration. And so the absence of riparian cover in the surface water area is absolutely prime for restoration, and you can use the tool in that way. There are many other tools that you all already employ that get at that, but I think that's another aspect. Thank you.
Great. Great question. So other questions? Yep. Haley, good.
Hi, I'm Haley Colding with Vermont River Conservancy. So if you stay in this hall after this talk, we are going to be talking about how we prioritize sites based on flood resilience. But I actually wanted to ask a very similar question about other aspects of conservation. So we've got stream geomorphic assessment data to help us understand certain stream reaches or parcels or watersheds that we prioritize. But what do you see as other tips and tricks for getting from this like multi-scale data to understanding where you're going out and trying to work first?
Great question. Vermont conservation design as a whole identifies something like 70% of Vermont as highest priority. So it's a lot of the state. And if you just think about it that way, on one hand, it sounds like, well, that's crazy. That's like so much. How can that be what's a priority? When you look at it as a map of what would actually disappear if we only went down to 70% of the state having natural function, Vermont would be a very different place. And when you think about everything we have now, what you're saying, Jens, to keep what we have now, we have to keep what we have now. So Vermont conservation design doesn't even do that. But I think absolutely we need to, when you have 70% of the state highest priority, we still need to prioritize within it for how we work. And how to prioritize, I think the full suite of things that we use in the conservation world should come to bear when thinking about how we prioritize within VCD. The one caution I'd say is that I don't think we should prioritize within the design by only picking places where there are lots of not just picking the hot spots where there's lots of pieces stacking up at once. Because I think that leads us to a road where we prioritize places that have multiple functions and we miss essential things like how do we build connectivity across the state. So I don't think we should just do this adding up of, oh, it's got this, this, and this, therefore that's automatically where we work. It might just be that we need to focus on connectivity or riparian restoration in some places, and that's also a priority. So I think using things like the geomorphic assessments of rivers and streams, using other assessments of like where there's conserved land or a lack of conserved land, all those sorts of things can be built into this. And I'll just say again that that's work that the Agency of Natural Resources, Fish and Wildlife, and partners through this Act 59 project are hopefully going to be digging into over the coming months to think about where within Vermont conservation design could you prioritize certain tools and what would be your lenses for doing that. Do you want to add something?
On Wednesday, I drove up Route 12. And I'm in Worcester and Elmore, and I was with a crew of VTrans employees. We were doing that Highways and Habitats training, all the orange vests that Bob showed. And your parcel on 12 on Bridge 90, where the North Cascades Trail blew out, it needs some work. That was incredible what happened there just recently, just incredible. And even with an intact forested system, that area still blew out. We lost that parking area. Our culvert, the culvert we were looking at was something like 15 feet underwater. And they're replacing it with a 83-foot span bridge, not only to allow for wildlife movement, but also to allow for greater river process. So the design allows us to think about those multiple values, and perhaps that you all chose that site for very particular reasons in terms of access down to the river and providing access for Vermonters, and that's incredibly important. What it also does is allow for connectivity across Route 12. And we have a collared moose that went from Bloomfield to Fayston and back up to Bloomfield and went within a few hundred meters of that culvert. Had that been a bridge, which will be in 2026, it would have been a very different scene in terms of being able to go under the bridge. So my point here is I think the conservation design also allows you to see your place in that larger conservation pattern, but also some of the other values that you're contributing to that maybe you didn't even intend to, or maybe you did, but it adds to the stack of values.
Okay, over here. Gotta have this thing. Gotta have that.
Hi, I'm Devin Snyder. I have a question about the geological diversity blocks. That sounds really interesting. I'm curious if you have, it also sounds really similar to some products that kind of exist on a national scale, like ecological site descriptions and the terrestrial ecosystem inventory with Forest Service. So I'm wondering if, and maybe like from the brief description, I'm not understanding the concept so much, but is there an effort to kind of tie this very Vermont product to a more major land resource concept or ecoregion, anything along that line. It seems like it would be really useful to like avoid redundancy because we have so many products that are really similar to this across the United States. But
Right. So there's a number of ways to classify the land. Maybe start with just a few of them. So the biophysical regions that we have here in Vermont tie into those larger EPA ecoregions and Forest Service as well, right, Liz? So there's a scaling that you can do right from those regions that we looked at. Then the underlying data we used for the geological diversity analysis was primarily land type associations, which I think relate. I don't know if these are all crosswalked, but you've got land type associations, ecological land units, which we've used to some degree, and then those tie into some larger products that I'm less familiar with them outside of the state and region. But yes, there's that crosswalk. I think what we were trying to do was not so much get too bogged down in the individual data layers that we're using, although, I mean, understanding them and being able to apply them correctly is key, but to take the data in a practical form that made sense and then use it to just extrapolate to what our forest blocks are comprising. So we don't necessarily need to know what's at every pixel in each forest block from that underlying data, although we could do that. But it's to know that using this one data set that we used, here's a whole collection of forest blocks that collectively seem to have the mix that's in the data set. I might just be further complicating this, but I guess I'm trying to say that yes, we know we can crosswalk and that there's a lot of products, and that for what we're trying to do with VCD, I think that becomes maybe like a secondary use. What's important is we were able to find a product, get the forest blocks identified that we needed to identify.
And one more point, I like the redundancy because the redundancy tells us that we're on a similar track. So when Bob showed both the conservation design and the staying connected linkage areas and the wildlands network and resilient and connected and showed the overlap there, that showed me that we weren't off in left field, that there's a great deal of scientific consensus that the areas that we're saying are highest priority, that there's a huge range of folks that are agreeing with that. So that redundancy doesn't actually trouble me. I know it's annoying to work with, I hear you, but I do think it also serves a useful purpose.
Great, we probably have time for one more question. Okay.
I'll just talk loud. So, Liz, since you mentioned in the beginning Act 59 and it's called 30 by 30 now, and the revamp of Act 50, where is all this work being incorporated in those acts and that?
Okay, so the question was, I think, that talking about Act 59, which is the Vermont Community Resilience and Biodiversity Law, new law as of 2023, and then Act 181, which is the revision or the update of Vermont's Act 250. And how does Vermont conservation design fit into those? Well, in a very broad answer is that they are cited. Vermont conservation design is cited in both of those, and is the underpinning of them in many ways. I've had lots of conversations with Representative Sheldon, who sponsored both bills, and her intention is that the goals, the 30 by 30 and 50 by 50 goals, are reached sort of explicitly in Act 59, but also in the update to Act 250. So where those places, the specifics of that are still to be worked out, and how does the matchup of the categories in Act 59, how does that match up with Vermont conservation design goals? And maybe Bob, if you want to say more about that.
Just real quick, we are working the Agency of Natural Resources with VHCB on that whole Act 59 process. The inventory was released, the final inventory was released just a couple of weeks ago. And the next stage of that 30 by 30 planning process is to really take where are we now and how do we get to that 30% conserved with all of the nuance that's in that act. And I think that's where Vermont Conservation Design will plug in, and I think exactly how is still yet to be seen. That's what needs to happen in the coming months. And I think there's going to be an opportunity for partner organizations, the public, everyone to weigh in on that, just as there was for the inventory process. And that's really a VHCB thing. Actually, there was a session concurrent with this that was about 30 by 30 in the planning process, and even mentioned Vermont Conservation Design. So you need to track down people who went to that session and see how that went. I'm curious about that myself. Thank you for coming.